Hi class, in this video I will show you how to solve homework 4.3 or from assignment 4.3 in my lab number 10. And so the problem says, shoot, I think I moved the problem. You open it back up. All right, so this is the problem here. Hopefully it gave me the same one I already copied. So what this problem says is that a consumer group claims that the mean minimum time it takes for a sedan to travel a quarter mile is greater than 14.6 seconds. A random sample of 20 sedans have a mean minimum time to travel a quarter mile of 15.4 seconds and a standard deviation of 2.08 seconds. At alpha equals 0.01, is there enough evidence to support the consumer group's claim? And then we are going to complete this. So we see it did change it a bit. So let me just change these. So it said that a consumer group claims that the mean time it takes to travel a quarter mile is greater than 14.6 seconds. A random sample of 20 sedans has a mean time to travel a quarter mile of 15.4 seconds, and the standard deviation is 2.08. And the alpha level is 0.01. Okay, so it's kind of cool. To copy this into Excel, I should have just recopied this. I just did this. And when I pasted it, it pulled it out in this fashion. Show you when I pasted it, pulls this out in this fashion where it has all my input pieces here. So let's go ahead and label these. So a consumer group claims that the mean minimum time it takes for a sedan to travel a quarter mile is greater than 14.6. So this is my claim. And my claim is that the mu is greater than 14. Okay, so that's what this piece is. So this is my claim, and that it's that the mean is, and it said right on here, is strictly greater than 14.6. Okay, and what this gives me is a random sample of 20. So that's my n. This over. So this is my mu. This is my n. So 20 sedans has a mean travel time of 15.4. That's my x bar. And a standard deviation of 2.08. That's my s. And this is my alpha level. Okay, so they gave us everything. And then they want to know, is there evidence to support the claim? So the first thing we do is we state the null and the alternative hypothesis. So since this is strictly greater than, this is the alternative, because remember the null always has the equal sign. So mu greater than 14.6 is my, and this is my claim. Okay, and then that means my null hypothesis is mu is less than or equal to 14.6. So this is the first part. So the null hypothesis is mu less than or equal to 14.6. And the alternative hypothesis is that mu is strictly greater than 14.6. Okay, and the claim is the alternative hypothesis. All right, and then it asks us to use technology to find the p-value, which and find the standardized, using technology to find the p-value, find the standardized test statistic t. Right? So remember, the critical t is the one that we look up based on the alpha level, but the standardized test statistic t is the one that we calculate. So t equals x bar minus mu divided by s over the square root of n. So that's the formula we use for t. T equals, it's just like z, except we replace the sigma with s. So we go equal, parentheses, x bar, 15.4, minus mu, 14.6, divided by, use a parenthesis, s, divided by the square root of n. So again, this is our t, our standardized test statistic. And the one that you look up in the table, they usually call that one T naught. So since this is greater than, this means we have a right tail test. So remember that a right tail test has a positive t-value, a left tail test has a negative t-value, and a two-tailed test has a negative and a positive t-value. Okay, and then next it wants us to find the p-value. And the p-value is t dot dist So let me show you how to do it. For the p-value, we go equal t dot dist. And since we, so t dot dist, this one gives you a left-tailed p-value. T dot dist dot 2t gives you the two-tailed t-value. I think it says, see, it says left-tailed. It tells you right here when you click it. This one gives you the left-tailed. This one gives you the two-tailed, and this one gives you the right-tailed. So it's t.dist.rt. And then we need x and the degrees of freedom. So x is our x bar. Oh, I don't know why it says that. X is our t. And our degrees of freedom is n minus 1. and our p-value is 0.05, 3 decimal places, 0.051. Remember, to make this to the right number of decimal places, we can just move our decimal places like that. Should have done that here as well. And you don't have to worry about making a rounding error. Okay, so I wanted to put in what that was. T.dist.rt and then it's your T, this number, comma, n minus 1. Okay, those are your degrees of freedom. So that's how we're going to put it in. So again, T.dist.rt, because we had a right-tailed test, which is based on the the alternative hypothesis. So if the alternative is less than, you have a left-tailed test. If it's greater than, you have a right-tailed test. And if it's not equal, you have a two-tailed test. So this is a right-tailed test. So then again, we use the T value and n minus 1 as the degrees of freedom in our, in our calculation. Okay, and then decide whether to reject or not. So we reject H naught if P is greater than P is less than alpha. Okay, but our P is greater than alpha, so we can check this. We can go equals if else. If, and then we can put in a test if P is less than alpha. But didn't put in the value. We reject, otherwise we don't. If we put it in like that, it'll tell us whether to reject or not. Move this down here. And let me put in alpha, which was here 0.01. I can put that into my formula. Right, so we do not, or we fail to reject H naught because the P value is greater than alpha. Oh, that was supposed to say if. Reject if P is less than alpha. Oh. All right, and then it wants us to interpret our decision based on the original claim. So whenever you don't reject, then you're always going to say there is not enough evidence. Whenever you reject, you'll say there's enough evidence. If we reject, then we say there is evidence to support the claim, since the claim is the alternative. And since we do not reject, we say there is not evidence at the, this is 0.01, so that's the 1% level of significance, to there is not evidence to reject the claim. So since we did not reject Oh, there's not evidence to support the claim. I didn't pull up my little chart. That the time to travel a mile is, the claim was that it's greater than, so we just put in what our claim was. The claim is greater than 14.6. So there is not evidence to support the claim because we did not reject the null hypothesis. But it's a lot easier to do this part if you use the little table. I just didn't have mine in front of me. All right, so that's how you do number 10. I hope that helps.